All right, we're rolling, so no cursing. Or less cuss words, right? Okay. This is, what's the name of this? Stoichiometry test review. Something.
Test review stuff.
And then what I'm about to do is already on video right here. Just in close up with just my hands, all right? So we're going to go over these problems. I'm going to have to move the document around a little bit so we can work it out. Here we go. All right, first problem here was we have this equation. We got this equation right here. Let me blow this up real big. All right, now we'll give us some space. All right, here's our first problem. And we'll move down a little bit. All right. So, questions 1 through 3 deal with this problem right here. 4 lithium atoms and an oxygen molecule combine to make lithium oxide solid, all right? If 4 moles of lithium is heated, all right, so, well, we already have 4. That little guy's going to drive me crazy. There we go. If 4 moles of lithium, so, okay, if we had a 4 here, well, we do, is heated with excess oxygen, so there's plenty of oxygen. How many moles of lithium oxide would be produced? Well, 4 is to 4 as 2 is to 2. So the answer to that's 2. Everybody agree? All right. Good. Done. And we're going to pull this back up. Tell you what I'm going to make a copy of this real quick so that we can mess it up. And then we'll work on this. All right, so we've already done this first problem, so I'm going to just get rid of it. All right? Okay. So the next problem says, this is really number 2 now, so it's going to mess with us. If 20 grams of lithium oxide was produced. Okay, now, we cannot put grams there. These numbers only stand for moles, right? So the first thing we have to do is change this 20 grams to moles. 20 grams over 1 times 1 over lithium oxide is 7 plus 7 plus 16. That's 30. Does everybody understand? Do I need to slow down? Go.
So you don't have to multiply by the 2?
No, the 2, I like the way you're thinking. You're like, oh, would I put a 60 there because there's 2 of them? But no, we do that, and then these numbers later balance themselves out. So if you made this 2 times 30, then you'd be using the 2 twice. So just watch for a second. So 20 grams is 0.67 moles. So we're going to put 0.67. And now we'll use the 2. How many grams of oxygen gas was used? So 0.67 is to 2 as x is to 1. So that's going to be 0.33. Everybody see how I got that?
No.
But that's 0.67 is to 2 as x is to 1.
Oh,
So half of that is that.
oh wait, I get
Yeah, this is really 0.666666 rounded. So half of that is 0.33. All right? But that's 0.33 moles. Says how many grams? All right, no problem. 0.33 moles. Oxygen is 32 grams per mole. So a third of 32. So it's going to be like 10.8 grams or something like that. What's the answer y'all got?
10.72.
10.7, something like that, 10.7 grams. All right, cool. All right, remember, you can go back and watch this again. All right, if 1 mole of lithium reacts, okay, if 1 mole of that reacts, how many grams of lithium oxide were produced? 1 is to 4 as X is to 2. We would say 1 over 4 equals X over 2. That's going to be X is equal to 0.5. Everybody agree with that? Okay. So that's 0.5 moles. But it said how many grams? All right, no problem. 0.5 moles of lithium oxide. That's 30. 15 grams. And somebody's like, where'd the 30 come from? Don't forget, 7 plus 7 plus 16. Everybody with it? Everybody feel good about it? Anybody got any questions? All right, so this whole, I'm going to delete this whole section. Again, people at home, and in here, you'll be at home later. Don't forget, you can go back and do this again. All right. These are really questions 4 through 6. Let me blow this guy up. Okay. I'm going to back this up a little bit just to get it into the middle. All right. All right. If 50 liters, okay, now, liters is volume. What is the unit we use for volume for 1 mole?
22.4.
22.4. All right. So 50 liters of pentane. Well, we can't put a 50 here. We have to convert 50 liters to moles. So the given times 1 over the proper number. I'll use my calculator to get the exact decimal on that one. 50 divided by 22.4. 2.23. All right. So 2.23. Everybody understand how I got that number? All right. 2.23 moles of pentane. How many liters of carbon dioxide? All right. So 2.23 is to 1 as X is to 5. These numbers are moles. 2.23 over 1 equals X over 5. 5 times 2.23 is going to be, is that 11.25? What is it? 11.15. I'm supposed to say, yeah, 11.16. All right. All right. So we get 11.16 moles. And then it says, how many liters? All right. Well, so it didn't ask for moles. 11.16 moles at 22.4 liters per mole. So times 22.4. Gonna give us 250 liters. Everybody like that?
Yes.
Seems straightforward, doesn't it? Everybody, all right, you with me? Okay, great. All right. Next one. If 45 grams of water was produced, all right, 45 grams. We've got to convert that to moles. Water we know is 18 grams per mole, so basically 45 divided by 18. 2.5. So really, 45 grams is 2.5 moles of water. How many moles of oxygen were used? Here's oxygen. 2.5 is to 6 as X is to 8. All right, we got that. 2.5 over 6 equals X over 8. 2.5 times 8 divided by 6. Times 8 divided by 6. 3.33. So it'd be 3.33 moles of this. Everybody feeling it? Okay. All right. All right? If 4.58 times 10 to the 23rd molecules of pentane, all right, we got to put a number here. 4.58 times 10 to the 23rd, we got to convert that to moles. Looks like a plus, but that's the times. That's how we convert it to moles. So 4.58 times 10 to the 23rd divided by 6.02 times 10 to the 23rd gives us 7.61 times 10 to the 22nd. Everybody agree with that? Is that right? No, just 7.76. I'm sorry, on my brain. I've been sick for 3 days. You know that. 4.58 times 10 to the 23rd divided by 6.02 times 10 to the 23rd is 0.76. 0.76 moles. All right. How many molecules of oxygen were needed? 0.76 moles would be how many moles of this? 0.76 is to 1, is 8, is x is to 8. It's going to be 8 times as much. So we hit times 8. And that gives us 6.08 moles. And then it says how many molecules? 6.02 times 10 to the 23rd molecules per mole. 6.08 times 6.02 EE23 equals 3.66 times 10 to the 24th.
Did you get the folder for Rosa?
No. I've been sick, girl.
I know you've been sick, but it's right here.
Okay.
Have you heard about the hose up in the jar?
Yes, the penny drop.
Yeah, you want to try some of these?
Okay, thank you very much.
You can get a piece of honey.
3.66 times 10 to the 24th. Everybody with that? All right. All right. Does that, we do all 3 of these? We done? Everybody understand these? So by this point in the test, we've done the first 6 problems on this old test. We've done moles to moles, grams to moles, molecules to moles, liters. We've done all the transitions, right? So these first 6 problems, like, that's it. That's all the stoichiometry there is, right? I mean, that's all like the different types of problems. Until we get to doing limiting reactants and stuff like that, we're really, if you can do what we've done so far, you can do anything. All right, so check this out. We'll do this next. Is this a set of 3 again?
Yeah.
All right, we'll do this next set of 3. I might speed up just a little bit. Are y'all comfortable with going a little bit faster? Or you? Okay. I guess if somebody's watching this on video, they can always just rewind it. Or I could talk real slow and then they could put it on 1.5 and I could be normal. That'd be difficult to do. Okay. If I want to react 2 moles of lead-2 nitrate, how many moles of sodium chloride should I use? X over 2 equals 2 over 1. 4. Everybody feeling that?
Yeah.
If 3 moles of lead-2 chloride is produced, all right, how many grams of sodium chloride were used? Okay, we got to solve for the moles for it. 3 is to 1 as 6 is to 2. I'm sure everybody agrees with that. So it's 6 moles, and it weighs 58.5 grams per mole. Everybody agree with that?
I'm a super
Ah, y'all.
I think it's weekend.
Hey, you too. Thank you. So what is that, 351? 350, my brain's working a little bit. 351 grams. Everybody feeling that? Good? Understood? Understandable? Anybody got a hand raised for this? All right. Commissioner Gordon, again. Hello.
Justice. Okay.
Okay. You gotta check out for. All right. If 2.5 moles of sodium nitrate is produced, okay. How many molecules of lead-2 nitrate were used? All right, we gotta solve for moles first. 2.5 is to 2 as 1.25 is to 1. All right, so 1.25 moles, but it says how many molecules were used. So 1.25 times 6.02 times 10 to the 23rd is going to be basically 7.5 times 10 to the 23rd, something right around there. Everybody feeling that? All right, good. So like I said, if you could do the first 3 on this test, you could do the first 9. They're all the same. They're just flip-flopping around. Is there another one after these?
Yes.
In the same section? Okay, no problem. Let me delete these out. All right. Now, move this down a little bit. All right. All right, have a good weekend, buddy. All right. If 25 grams of sodium chloride is used, all right, we can't write 25 grams there. We've got to convert it to moles. 25 over 1 times 1 over 58.5. Okay. Figure out how many moles that is. 25 divided by 58.5 equals 0.427. I'm going to call that 0.43. 0.43. How many compounds of lead-2 chloride is produced? Well, we got to solve for moles first. 0.43 is to 2, as x is to 1. I've already got this number in my calculator, so I'm just going to hit divided by 2. And I get 0.214 moles. So now we can figure out how many compounds is that. All right. 0.214 times 6.02 times 10 to the 23rd. So that's going to be 20% of that. 1.2 times 6.02 23 equals 1.2, a little higher than I was going to say. 1.29 times 10 to the 23rd. Everybody feeling that? Okay, cool. All right. And that's the end of that section. All right. All right, this is our equation we got right here now. Make that up a little bit, make it bigger. All right. We want to make, this is that, this is that, is that, this is the same thing. We're not doing anything. Do you guys want to do these? Or if you want me to do these, I'll do them. All right, let's do them, man. Still not doing any limiting reactants yet. All right. We want to make 100 grams of aluminum. We can't write 100 grams there. We have to write moles. 100 over 1 times 1 over 27, basically. Everybody understand where I get that from? it's really 26.98. I think 27 is going to work. 100 divided by 27 gives me 3.7. 3.7. So if we want to make 3.7 moles of aluminum, how many grams of aluminum oxide should have been used? All right. 3.7 is to 4 as X is to 2. So we know this number is going to be half as big. Everybody agree? Y'all can stop me. It doesn't matter if we're filming. Stop me if you don't know what I'm talking about. I feel like everybody's been shaking their heads the whole time. Yes, just say yes, I do know exactly what you're doing.
Where did you get the 3.7?
Where I get the what?
3.7?
I did 100 divided by 27. Yes, 3.7 mole, 100 grams of aluminum. So I had to divide it by 27. Yeah. All right. How many grams? All right, so 3.7 is 4 is X is a 2. In other words, this number's going to be half as big. So 3.7 divided by 2 gives me 1.85. That solves our ratio. 1.85 moles of this. How many grams? 1.85 times, let's add this up, 54 plus 48. It's 102, right? I wrote 162. 102, right? 1.85 times 102 gives me 188 point, I'll call it 9. Know it? Yep. Marion, tell me what you're thinking about there.
I'm a little confused.
Okay. All right. All right. All right, what I want you to do is tell me to stop when I do something that you don't know quite why I did it. All right? How many liters of oxygen gas released when 2 moles of aluminum oxide are added? 2 moles, and we're worried about the oxygen gas. First thing we have to do, solve for the moles. 2 is to 2 as 3 is to 3. Everybody agree with that? So it's going to be 3 moles of oxygen gas, but it said how many liters? How many liters are in a mole? 22.4. So that's it. What's that, 67.2? Right? Okay. I'm sorry, y'all. I started going faster because I thought I took the silence as total comprehension. Not bad on that. All right, here we go. 500 grams of aluminum oxide. All right, we can't write 500 grams there, so let's go ahead and convert it. 500 grams over 1 times 1 over. Remember, this is 54 plus 48, so that's 102. Figure out how many moles that is. 500 divided by 102 equals this 4.9. How many grams of aluminum metal is produced? 4.9 is to 2 as X is to 4. So this number is going to be twice as big. Everybody agree with that? So 4.9 times 2, we know that is 9.8. 9.8 moles. But then it says how many grams. So we know this number is 9.8, right? But how many grams? Well, how much does aluminum weigh per mole? 27. 9.8 times 27. 264.7. Everybody feeling it? Right? Okay. All right. If 5 moles of aluminum were produced, we made 5 of that. How many liters of oxygen were produced? All right. First, we got to solve for moles. 5 over 4 equals x over 3. Cross multiply that. 3 times 5 divided by 4. 15 divided by 4. 3.75. I can't believe I used a calculator for that. 3.75 moles. So 3.75 moles, but it didn't ask us for moles, it said liters. There's 22.4 liters for every one of those moles. Times.
Did you do 5 over 3 to get 3.75?
Did I do what? I did. I did 5 over 4 equals x over 3. Is that what you're talking about?
Yeah, but what did you multiply or divide to get 3.75?
Okay, ready? I did this. 5 over 4 equals x over 3.
Yes.
Now just cross multiply. 3 times 5 divided by 4. Right? All right. So 3.75 times 22.4. Give me 84. Everybody feeling it? Okay. All right. Get rid of this guy. All right, and this is different. Oh, okay. Different problem. We're still dealing with the same type of stuff though, right? Still no limiting reactor? Man, this is a long test. Your test on Monday will not be this long. All right. Here we go. If 5 liters of chlorine gas are added, all right, we got to put a number here, but we can't put liters there. 5 liters over 1 times 1 over, what's the proper number for liters? 22.4. That'll give us our moles. So 5 divided by 22.4, 0.22, 0.22. Yeah, it really's got a 3 there. I'll leave it. I don't know. Whatever. 0.223. How many grams of magnesium chloride were produced? Okay. 0.223 is to 1 as 0.223 is to 1. But this 0.223 stands for what? Moles. 0.223 times how much this weighs? That's going to be 24 plus 70.8. Everybody understand? I'm just doing these fast. That's 35.4 plus 35.4, right? So that is 95.2, is that right? Everybody? All right. 0.223 times 95.2 grams. 21.25 grams. 21.25 grams were produced. Anybody got a question? All right. Okay. Remember, you can always just watch it again. Oh, it's our last one before we get to percent yield. Thank God. All right. It's getting a little long. All right. Stay. All right. Whoa. All right. Magnesium, 2 moles of magnesium chloride were produced. How many grams of magnesium were used? 2 is to 1 as, well, 2 is to 1. So 2 moles there would end up being a 2 here. How many grams? 2 times 24, is that 0.3, right? 2 times 24.3. No one could ever do 48.6 grams in their head, right? Make sense?
Yep.
All right. If you are confused, realize we're doing the same thing every time. The only thing we're doing is any numbers that they're giving us, we're converting to moles, and we're putting them in a fraction right here. Then we're solving that fraction for the next thing they ask us about, and then we convert it back into the new number they want. That's all we're doing, over and over and over and over, right? That's it. And if you want me to say that again, rewind it. Right? I mean it. I don't mind. All right. Get rid of all this stuff. Here's the good stuff at the end. Percent yield. All right, I'm going to go slower now. We'll start going slower. Because we have not done this in person together. If anybody's watching this video from another year, I've been sick for the last 3 days. I guess I only have 2 years left of watching this video. But the county kills my YouTube channel when I retire. Haters. All right. I've only got 58,000 subscribers, you know? Yeah, literally.
Only 58,000?
I was kidding. I think that's a lot. Better than my podcast ever did.
Why would they have to cancel it?
They like to wipe you out of the system when you're gone.
But it's YouTube.
Oh, the problem is, like, I don't know if I could keep it. Maybe I could ask him, but, you know, I'll be building houses, so I don't know. Huh? I can't hear you. I just don't hear. Well, all right. Anyway, but like they own my email, so the YouTube channel is under my Gmail account, which is under this email. So yeah, I'll probably just do it. Yeah, I'll probably then I can if I can I will just to leave it up just for kids, just for the good of kids. Yeah, I mean it's not like I want to make money off of it. I just like to leave it up because I've done all this stuff like we're doing right now. Some kid in Oklahoma is going to watch this video, and right now some kid in Oklahoma is like, "What? How would he know this?"
Do you make money off of it right now?
No.
How much subscribers do you have to
Huh?
How many subscribers do you have? My brother has 300 subscribers and not active.
Well, I just don't have it
Wait, that's not the
monetized.
school email. Oh, you should.
All right. So, what does it say?
It's not the school email though.
What does it say?
Well, that's never mind.
How many subscribers does it say?
57.6.
Oh, that's right. I lost some. The reason I lost some was and I'll get them back in February. I put out these shorts. A lot of the ways I got a lot of these subscribers that have put up these YouTube shorts of the physics projects, and some of them are pretty crazy. And then people subscribe through the YouTube shorts. But then after I put out long boring videos like this, kids unsubscribe. They're like, why am I getting this stuff about chemistry? I want to see stuff blow up. Right? All right. Here we go. So we're going to talk about the percent yield of calcium oxide. All right. Now, this is so easy, y'all. It's just literally one more step. I'm serious. All right. If we added 40 grams of calcium carbonate, all right. If we put 40 grams in there, let's just convert that to moles. 40 grams over 1 times 1 over, let's see, it's going to be 40 plus 12 plus 48, 60. Wow, it's 100. I can't believe I didn't know that. So that's 0.4 moles. So 0.4 moles, that's our 40 grams of calcium carbonate. And then we made 20 grams of calcium oxide product. Well, first thing we need to do is see how much we should make. Does that make sense? If we have 0.4 moles of this, we should make 0.4 moles of that. Does everybody agree? 0.4 is to 1 as 0.4 is to 1. All right, so we should make 0.4 times 56. Everybody see where I got that 56 from? That's 40 plus 16, right? So we should have made 40% of 56 grams. So we're going to say 0.4 times 56. We should have made 22.4 grams. However, now we look at the number they gave us. We only made 20 grams. So basically, 20 out of the total you should have made is your percent yield. That's all. You only made 20 out of the 22.4. So 20 divided by 22.4 equals, you made 89% yield. That's all. The only reason this would screw you up is if you saw this number and tried to use it before the end of the problem. Does that make sense? It's the only way. Like, you calculate how much you should have made. We should have made 22.4 grams. But we only made 20. Therefore, we only made 20 out of how much we could have made. So we only made 89%. That makes sense? There's a really famous scene in Breaking Bad where he realizes, where Walt realizes that Jesse's taking like 2 kilos of meth because he does the percent yield, and their percent yield is normally like 97%, which is super high for a chemical reaction. And he knows how much it is. Huh?
What?
So, one of the things that we would talk about, had I not been sick this week, was that chemical reactions don't produce 100% of what you expect. Nothing ever works out perfectly. We're talking about trillions and trillions of atoms needing to collide with each other. Does that make sense? So, you never get a perfect reaction. That's just how it works. So, 89% yield isn't bad for a lot of reactions. Let's try another one. Let's get rid of this one. All right. Here, this one right here. If we added 75 grams of calcium carbonate, all right, 75 grams over 1 times 1 over, remember this weighs 100 from the last time we just did it. So 0.75 moles, right? 0.75. If we had 0.75 moles of calcium carbonate, determine the percent yield of carbon dioxide. Well, let's see how much we should have made of this before we use this number right here. See what I'm saying? I didn't even read that number. Right? I just said, oh, carbon dioxide. How much should we make? 0.75 is to 1 is 0.75 is to 1. So we should have made 75% of liters. Liters, okay. 22.4, right? We should have made 75% of that total 22.4 per mole. Take our calculator, 0.75 times 22.4 equal marks us. We should have made 16.8. But we didn't. What should we make? Now you can see it. 15, right? We only made 15 out of the 16.8. We take our calculator. We say 15 divided by 16.8 equals, wow, that was a total accident. 80.89 or 89% again. 89% yield. Just like the last problem. That's weird. I didn't do that on purpose, I guarantee you. Everybody feeling that?
Yes.
All right. And then it switches up down here a little bit. We got a new formula now.
Okay.
Blow this up a little bit.
I'm good.
Y'all feel good about that?
Yeah.
Are y'all laughing at me? Did I say that too much? Huh?
No.
No, I probably do. I literally mean it though. I literally do mean that. All right, so I'm gonna make this red so it stands out from the rest of the stuff. I guess that's gonna be a lot of trouble, isn't it? No, it's not. All right. Okay. First thing. All right. So this is like being at McDonald's, and you're saying, no, there's no lead-2 nitrate in a Big Mac, I promise you. But this is like being at McDonald's and saying, okay, we've got 31 buns, we've got 14 hamburger patties, and we've got 12 pieces of cheese. Which one of these is going to keep us from making the burgers? Does that make sense? Which one is going to be the number? Which one of these is the one that messes us up the most? Does that make sense? Which one holds us back? Which one is the limiting one? All right? Now, if we were making Big Macs, a Big Mac takes 3 buns, right? And then there's 2 patties, right? So if you had 30 buns and 30 patties, you don't have enough buns. You don't have enough buns to make 10 Big Macs. So the buns are the limiting reactant, not the patties. Does that make sense? All right. So you got 21 grams of NaCl and 32 grams of lead-2 nitrate. All we do is do the problem twice. That's it. Like right here, that's Christmassy. Right here, all we do is we do the problem with 21 grams of sodium chloride, all right? 21 grams of sodium chloride, 21 grams. And I guess we're trying to make this 21 grams. 21 over 1 times 1 over its salt, so 58.4. Anybody not know what I'm talking about there? All right, 21 divided by 58.4, because that's NaCl, 0.36. 0.36 is to 2 as, we're looking at lead-2 chloride, x is to 1. 0.36 over 2, x over 1, it's going to be 0.18. So we can make 0.18 moles. Everybody with me? I don't have to go any further. I can make 0.18 moles by using the salt, using NaCl. All right, cool. I'm just going to leave that there. I'm going to forget about it. Now I'm going to do it again with the other reactant. All right? Now we're going to mark this out. All right, 32 grams of lead-2 nitrate. All right, 32 over 1 times 1 over, Lord, 48, 62 times 2 is 124 plus 207, that's 331, okay? We're close enough, right? Everybody with me? So 32 out of 331 is like 0.099 or something. Let's just do it. 32 divided by 331 equals 0.097. Wow, so far off. 0.097, 0.097 moles is to 1 as x is to 2. So we got double that. I'll hit times 2. So it would make 0.19. So 0.19 moles, that's terrible handwriting, using PbNO3 2. So, which one's the limiting reactant? The salt. The salt's what's holding you back. So how many grams of, who is the limiting reactant? NaCl, because it would only make 0.18 moles, right? Everybody with me? Okay, and then how many grams would be produced? So now at this point, you just finished the problem. Which one of these problems are we going to finish? This one, the one that makes the least, because that's all you can do. Now you're the manager at McDonald's, and you tell the other workers, hey, we only want to make 10 Big Macs. And you have the one kid that doesn't understand, and you have to just say, look, just make 10 Big Macs. All right, we're going to finish this. 0.18 moles of lead 2 chloride. So 0.18, how many grams? PbCl2, that's going to be 207 plus 70.8. $277.8, I guess. Am I right with it being 207?
Yeah.
I haven't looked yet. 207, so 277.8. And kids in other states, yes, I'm leaving off some little numbers, but I can't see the board from here. Just doing it from memory. All right. 0.18 times 277.8. 50. 50 grams. Does this make sense to you, what I just did? Raise your hand if it doesn't make sense to you. Like, I don't know what you're talking about. All right, so nobody's totally confused, all right? Let's try another one.
He just put it was point the lead nitrates, but he used the NaCl.
Okay, that's it for that one.
I'm just, no, I got it.
All right. Look, if you don't quite get it, go back and watch it again. For real, though.
Okay.
All right, here we go. All right. So, these questions are kind of backwards. Really, we should just figure out what the limiting reactant is first. It doesn't matter. I spell liters like everybody else in the world that doesn't live in the United States, so my bad. All right. If 34 grams of C5H12 pentane and 12 grams of oxygen are reacted, which is the limiting reactant? This is the question we should really answer first. All right? So what we're going to do right now, yes.
I'm confused. I thought gases are supposed to be liters. Am I wrong?
You thought what?
Gases are supposed to be liters. Am I wrong?
Well, you could measure it, you could weigh it too, right? Like when I go to Ace and buy some propane, the container's so big, and they know it's full by weighing it. It's literally sitting on a scale there. Yeah. So you're just saying you thought this problem should say if so many liters of this.
Yeah, I just thought.
Yeah, it doesn't matter. They just got to be grams, so we just solve it for grams. I hear you. What you said is not like dumb or anything. I get it. I mean that. Wasn't a dumb thing. I know where that came from. That's what I'm saying. 34 grams over 1 times 1 over, let's figure out how much pentane weighs. 60 plus 12 weighs 72. Right? So 34 out of 72 tells me that it's 0.47 moles. 0.47 is to 1 as, we're looking at how many liters of carbon dioxide we produce. 0.47 is to 1 as X is to 5. Okay? Let's see. 0.47 over 1 equals X over 5. So we're going to cross multiply. 5 times 0.47 times 5. I kept all the stuff in there. 0.236. So that would make 0.236. Yeah, 2.36. I was like, that's not right. 2.36 moles. So if we use the pentane, 2.36 moles are produced. All right? Now let's do it with the other one. Let's do it with this one. If 12 grams of oxygen were used, 12 grams, we've got to convert that to moles. Times 1 over O2. Everybody knows what that weighs, right? 32. 12 divided by 32 gives me 0.375. 0.375. But see, now look, you got to go ahead and finish the ratio because this had a 1 there. This has got an 8 under it, right? So you have to keep working. 0.375 is to 8 equals X over 5. So now we're going to cross multiply. 5 times 0.375 divided by 8 times 5 divided by 8 on my calculator gives me 0.234. That was 2.36. And this one is 0.234. It's like a tenth. So this is the one that makes the most. So this is the limiting reactant. The one that makes the least is the one that we have to finish our problem with. Everybody with me? So 0.234 is the one that holds us back. So who is the limiting reactant? The oxygen was. How much is going to be produced? 0.234 liters, 0.234 moles, and each mole is 22.4 liters per mole. 0.234 times 22.4. It's only going to make 5.25 liters. That's the limiting reactant. Is that the end of it? All right. Cut my phone off before it explodes.